Okay. Today I'm going to discuss uh, about recursive function, or you can say recursion. So in the last class we talked about the functions, and we have learned how write function, what the basic syntax. So recursion is also one of the form of the function itself. So till yesterday we talks we are defining one function. Okay, defining one function. Function can take some input, and after that they execute the block of code, and function can return the value if needed. And first define the function, and next going to use this function, call the function, what are the input parameters the functions are extracted. Okay, so this is a good almost all the kind of code we can follow this syntax. Okay, so today we are going to talk couple of example to writing these functions, and one of the also form of the recursive function. That means whenever you are defining function, let's we define function. Okay, and this is our function. Take our input, and a function body. Okay, so is it possible within the body of the function, can I invoke the same function again invoke the same function itself? Yes, is it possible? Generally first we defining the function, and the later part we are invoking the place where we want. But also possible whenever you are defining function, within a function body you can also invoke the same function. So this situation, this the way of writing code known as a recursion, or this is function is a recursive function. The recursion is the way where you can invoke a function within itself. Okay, so same recursion is a fundamental concept in the programming where a function call itself repeatedly until it's reached the base case that stop the recursion. So here in recursion, one of the very key, let us this is your functions body. Okay, and this is the function name, let's say f, and you all invoke again. So whenever this code execute this line, once they reach here, they again go to the call this function itself, again execute this line, again call. So look like this become a infinite works. They are never ending kind of code. Okay, you are going here, and again call the same function go to again here. Okay, then here again. So this is never ending kind of a code. This is known as a infinite loop. Your program is going to continuously running in the loop. So in case how to avoid the, somehow we have to write some condition here after a specific iteration. Let's say 1 time, 2 time, 10 time, 20 time. I have to break the condition and say, hey, stop, don't go again call this function, go outside of this function, so that your program can be terminated. This is known as a base case. So the recursion, a recursive function, whenever you are thinking you are going to write, be carefully thinks after what number of iteration our function going to stop. In other words, a function solves the problem by breaking down its smaller instances of the same problem, which are then solved the same function until the solution is original problem is found. The recursive function also helps to do the same operation, whatever the code you already did for the x input, same you want to do for the y input, same for the z input, same for the p input. So in this scenario you are going to use the recursion. The recursion also help us to solve your problems, bigger problem to the smaller, so that the same smaller can be executed. So these are the some key elements of the recursion. First, base case. The base case is a trivial case that can solve without calling the function recursively. It serves the stopping point of the recursion. So base case is the conditions on which base you have decided my recursive function going to end. Going to end. The recursive case is the case in which the function call itself a smaller instance of the same program. And depth, recursive depth refer to the number of times the function call itself, sometimes known as. So this function may be called 2 times, 3 times, 4 times, 5 times. Those known as a recursion depth. So this is the basic terminology we should aware. Okay, so generally, whenever you are going to write the code, recursive can be in three mode. Maybe direct recursion, indirect recursion, or manual recursion. That means direct means your function call itself directly. So you have a write a function this, your body, function body. Here you call again the same function. This is the direct recursion. Indirect recursion, a function call another function which call the again. So this is a scenario where a function this call this, and here you call another function f1, go f1 internally call to the again function f. So you can come again here, again f1 call, again f call, again f1 call, f call. In this way become a recursive. Mutual recursion means two or more functions call to each other recursively. So the permutation combinations you can make. Final objective, the same function can invoke directly or indirectly, some anyhow. Those the situation considered as a recursive function. And whenever you are going to work, so be carefully, you should be aware. So your initial call means your function going to invoke the initial input, check for the base curve, recursive call, and repeat steps 1 2 3 times 4 times as per your need. And then you can think how my recursion going to stop, going to return the value. And finally the recursive have a concept of backtracking. The number of function invoke. Okay. So here say you invoke this function for that you call the fn for one input. Okay. They call this function. Internally you can call again this function, another function. Okay. Again you call the same function again. Again you call the same function again. Once you stick now stop. This function again cursor return go to the back here. This function go return back here. This function go return back here. This is known as a backtrack, and finally the call function get the output. Okay, so finally you are calling function 1, then function 2, then function 3. So finally the initial which started the call, this is started the call, they must receive the value. So they is the concept of a backtrack. The recursive function is going to back from where they are invoked. So let's look the one example so that we can get understand. Factorial of, so what do you mean? Let's understand what do you mean by factorial. The factorial is a mathematical concept. Let's see, I say factorial of 5. Factorial of 5. That means ki 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1. This is known as a factorial of a given number. Okay, so this is the our problem ki whatever the number, anyone here can be 5, 6, say 10. So we are going to solve. You notice the what we are doing here. You are going to the multiply 5 multiply by 2, again the multiply, again the multiply, again the multiply. That means the same, you have a two number a multiply by number 2. Okay, number 2 at same actions you are going to do the multiple time. Okay, so this is known as a basic concept of the factorial. So first things, whatever the program or software going to write, first you should understand what the things you are going to do. If someone say write the code for the factorial, the first you understand what do you mean by factorial. Then we think how our programming approach solve this problem. This factorial problem can be solved a couple of way in the Python. Okay, surely we are just started learning write the code, so maybe let's discuss couple of one two. But in the Python programming language, this code one factorial of a given input number n, you can do the n number. Okay, so let's understand some basic way. Okay, so one, surely using the recursive function we are going to take, and let's think how we can write the this code again. Okay, so our objective, let's we have a input 5, so our objective would be the 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1. This is the factorial of 5. Okay, factorial of 5. So how will solve this problem? So let's understand slowly. You have a write a function. Let's say my function, let's factorial. Okay, factorial. It will take the input. It will take the number. Okay, number input, and you have to return the let's have it just a number. Okay, and this is the print factorial of let's 5. So this is the simple, we have written one function and return the value, and you are printing, you are using them. So here defining, you are using them. Okay, okay, just comment code here. In this way, you write in the comment code. Okay, so that's fine. But our objective not return the 5. We have to say 5 multiply by 4. That means whatever the number we have, just do -1, then get some number. So somehow, if you have a number 5, we have input number 5. Okay, from this I want to, if we did -1 here, then you can get the 4. Then you can multiply 5 multiply by 4. Okay, then you get the number. Okay, and whatever the 4 we have, again do -1, then I get the next number 3, then again do multiply. So somehow whatever the initial number I have, if I do -1, then I can get this. If I -1, I can get this, I can get this, I can get this, I can get this. So clean it. So here, if you be carefully think, so if we have a number, if you number -1, you can get the next number. Okay, next number. Okay, so now we have a next number and we have a number. If you multiply them, number multiply by next number. Okay, so in the programming, this symbol is for the multiply. In generally mathematics, whenever we learn, This is the cross X symbol is for the mathematics multiplication, but in the programming in the computer, star is for the multiplication. So if you run here, then you can get the 20. But this is not objective, just multiply by 2. Again, we need a third number. So maybe you can say, hey, oh, what you can do maybe next to next number equal to, you can say whatever the next number minus 1. You can say here multiply by next number. Okay, code format. Okay, this way you can, but this is the very hard to know. If let's say 10, 20, how many number are we going to minus, minus, minus? So same things you are doing, then we have to, whenever you are thinking, you are just going to the multiply, again multiply, again multiply. So why not think in the concept of repetition of work? Same as a mathematics you think, so we are doing 5 multiply by, you are doing 5 multiply by 4, right? And again, whatever the result, multiply by 3. Again, result, what, multiply by 2. So you are doing just multiplications of two number. Multiplications of two number. You are doing the same for multiple time. Okay, for multiple time. For multiple time. So whenever same operation you are doing multiple times, this is the number of times that it is. This is a good candidate for your make a concept of loop. So here, now we are going to write program not this way, but let them comment, remove it. Okay, remove them. Simple say, hey, we have a product multiplication equal to 1. Okay, let's start with the multiplication one. Whatever the number we have, whatever the number we have, whatever the number we have, again say multiplication equal to whatever the multiplication we have, multiply by number. Okay, and these things I can do. Why I am doing to this? So first I take one variable multiplication. This is the multiplication. Initially I am taking 1. Okay, and now I say, hey, I'm start from here. Okay, this is start from 1. Then multiply by 2. So I am say, hey, multiply equal to whatever the value, let's multiply by the next number. So let's start with the 1, then 2, then 3, then 4, then 5. So two-way programming can be think. You can start from maybe from here just 1, then multiply 2, then multiply 3, then multiply 4, then multiply 5. This is the one way to solve the problem. Another way, no, 5, then multiply by 4, then multiply by 3, then multiply by 2, then multiply by 1. In this way we can source. Think. So whenever you are writing code, you have to open your mind to think solution from the different approaches. Okay, so here we have option. Now we have a number. From number we can say let's minus, then minus, then minus, then minus. This is the one way. Another way, let's number 1 and then plus, then plus, then plus, then plus, and reach here. So both approach you have. So let's clean it. So here say let's a simple approach. I can say, hey, I am going to this same thing I can to do multiple times. So how many times? Until this number is not going to 1. I can say, hey, loop while this number greater than, let's say, 0. Okay, greater than 0. Then you multiply them, and after multiply you can say number equal to number minus 1. Okay, and after they can say whatever the multiplication return there. So what you are doing here, whatever the number we have, first multiply, then again minus 1, again minus 1, then again minus 1, you are get the value and you can run. So now you are getting. So let's print how you are getting this number. Okay. So here you can say just print your number, whatever the number you have, and your multiplier. Just these two number you can print. Just code format. Okay. Code format not works. Alignment should be same. Alignment should be same. This is the part of while loop, and this is the part of your main function. Okay. So be careful. This is your variable, and in this way you can get. This is one way. Your initial number was the 5, and you can set multiply by 1. So first what you did, first your number 5, and then this is the multiply 1. So you can say 5 multiply by 1, then we can again multiply 5 1 is 5. Okay, then this is the come, you can make a 5, then say number minus 1, number this, then it will become a 4, then you can 4. Now again go to the loop, number greater than, yes, 4 is the greater than 0. Then what say, you can just print this 4 and 5. Now I print 4 and 5. Now you can say multiply by 5. So whatever the multiply 5, multiply by 4, you are getting the 20. Okay, here number divide by, so number become a 3. Then you can go to the loop. Again is this greater than 0? Yes. Now we have a multiply, we have multiply by 20. Now is the number is 30. Again say, hey, 20 multiply by 3. This become a 60. Okay. Now again a minus. 3 become a 2. Now you go to the again loop. Check number greater than, yes, 2. 2 is still greater than 0. Let's go here. Again now become a 60. 60 multiply by 2. You are getting 120. Again go. Number 1 greater than 0, yes, go. Then again 120 multiply by 1 equal to 120. So somehow you are able to get the all the 5 4 3 2 1 and multiply by 1, then 5, then 20, then 60, then 120. Finally you get the output of 120. So this is the one way you can think, you can do. So whenever you are going to write code, be carefully think the different approach. This is the one approach. Okay. Or okay, this is the one approach. Or the same thing you can write, hey, let's 1. So instead of minus, you can, let's start from the 1 and just multiply by the 2 then 3. So instead of, let's uh, check our instead of here you can just take one variable initial in a variable a, okay, initial, and say here multiply, and here you can say a, and here you can say a equal to a plus 1. So here say this is the number 1, and until the here until this number is here, you can say until a less than or equal to number. So here you are starting from this way. Here you can say I am going to first 1 1, this is the 1 1 less than number, we have a number 5, This is the less than, yes, it's 5. Go multiply by 1 and a 1 multiply by 1, you can get the result 1. Again you say 1 equal to 2, now it's become a 2. 2 again, 2 less than 5, yes, 2 multiply by 1, again you can get the 2. Again this become a 3. 3 3 multiply by your result 2, you getting the 6. Again 4 4 multiply by 6 become 24 in this way. So here you can go and checking this condition is going till thus the a is less than or equal to 5. So in this way you can also solve the purpose. So here if you print, so here let's say this is the one. So you can check those both must be same. So both here getting the same number. So just here in this approach you will notice first 1, then 2, then 3, then 4, even you can print here a, okay? Then you can get the number, okay? So now this is the 1, 2, 3, 4, 5. So you can think from the 5, 4, 3, 2 minus way or plus way, but you can solve the problem. So this is the simple way you are solving this problem. Okay, this is known as a simple function. You are writing factorial and solving. So now take the concept of the recursive function. Recursive function say you define your function and first define your base case when you want to turn. So in the case of my factorial, if my factorial 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1, and after that I am going to stop. So here if my input number is 1 or 0, I am going to stop. So if number become any 0 or 1, if factorial of 0 become a 1, okay, so we have to stop the loop. Else this is the number is not this is not number. This is the here. Then we again continue, again continue. So call the same function. So here what we're doing, this is the number n, this is the number n, this is the number n, then multiply by n minus 1. So whatever the number, you are just going to the multiply by n minus 1. So this is the things you are doing to multiple times for the 5, for the 4, for the 3, for the 2, for the 1. So same this. So in factorial, you are just going to the 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1. So here your number is whatever the number n multiply by number minus 1. These things is your function code you want to do first time for 4, then for 3, then for 2, then for 2, then for 1, and after that stop. So here say if n become 1 or 0, then we can say stop, else call this function again and again. Number multiply by next factorial. Okay, so this is known as your recursive function. Within a function, this is the function, this is the function. In this function, you are calling the same factorial function. So from here, line go to the here. So let's, so here, let them just remove everything. Let them. So here you can go say, hey, def function factorial, that's a 2. Yeah, recursive. Take your number. Recursive. So here recursive function say two case always. We have to first when this function going to stop. So you can say if our case if a number become let's say 1, then we simply return 1. Okay, or you can say number become 0 or 1. Only things you can return the 1. Okay, else If not a number 1, then what will do? Just return whatever the number we have, whatever the number we have, whatever the number we have, just going to the multiply by, and which number? So here say we have a number 5, 5 going to multiply by which number? Next number. Next number what? 4. But I don't know 4. So I can say n minus 1. So here say whatever the number 5, 5 minus 1. This is the 4. That means what is the 4? 4. So here say, okay, this is the number become a, what number become? 4. Okay. So you are saying ki this is the 4, then 4 multiply by next number, again number n minus 1. 3 minus 4 minus 1, 3. So you can say, okay, 4 minus 3 again. So again function call it, over say here 3. So 3 multiply by what number next? 3 minus 1. It will become a 2. Then it will become a 3 multiply by what number? Oh, sorry, 2. 2 multiply by 2 multiply by 1. So here again, what this sum? 2 multiply by 1. So in this way, you know, if 2 then become a 1. What is the 1 case? If 1 then return we 1. If this function 1, then they're not going to call recursive. They say, hey, you are getting the 2 multiply by 1. So this result go to the back here. 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 So now here know what number they are going to multiply. This is known as a back test. 5 multiply by factorial of 4. 4 multiply by factorial of 3. 3 factorial of 2. 2 factorial of 1. Factorial of 1, I say 1 equal to 1. So they return. So here say number multiply by factorial recursive, again the number minus 1. So you can say go before multiply, first find out the number minus 1. I am going to waiting till number minus 1 multiplication come. Let's comment out. Let's comment out. Print 5. So this is known as your recursive function. So in this function body, you are calling this function inside the function itself. Now you are getting the same output. So here notice, look like this is a very concise, very simple code, right? Compared to what the same thing here doing, same thing here doing. But here look like very concise and simplest way code. So let's again understand how it works. Here you pass and here you pass 5. Okay, 5. This function called the recursive function. That means this is the recursive function call with input 5. This function check n equal to 1. This function check if ask the function call recursive function 5. And first check number equal to check is number equal to 1. This is 1. No, this is not number equal to 1. Then we can say ki number multiply by factorial of n minus 1. So you can say else part, go else part, say ki number 5 multiply by factorial of 4. Again you can say I am going to call the function for the factorial of calculating 4 by n minus 1. So here you can again going to the call, for the this time number is the 4. You can say this is the function called 4. Is 4 equal to 1? No, it is not 1. Then you can say go again calculate. Here number this time 5. You can say 5 or 4. 4 multiply by and go calculate the next number. So you can again call the function and you can say I am going to invoke the third. Okay. Again you call here, this time it is the 3. So you can say hey, this is the 3 input, 3 equal to 1, 3 equal to 1. No, it's not 1. Then go again calculate 3 multiply by find out the factorial of this time 2. So this time again invoke for the 2. Here say you receive the 2. 2 equal to 1. No, it's not 1. Then again calculate 2. 2 multiply by factorial of 1. In this time again you call for 1. This 1 equal to 1. Yes. This my base condition is match. 1 equal to 1 equal to true. So they not going to the call again factorial. So here I am not going to the call same function again. I am going to say, hey, I am just returning the value 1. So where they are going to return 1, they are going to return to the this place where they are waiting. So they are going to return to the here. And finally they are calculating 2 multiply by they return 1. The 2 multiply 1 equal to they return the 2. So where they return to again call function to the here. So this finally find, oh, I am find the 3 multiply by 2. That will become a 6. Where this 6 return? 6 return go back to the again to this function. They find 6, 4 multiplied by 6. Again say, okay, this is the 24. Where they return? Again they go return to 4 here. Then again say 120. Again, where this return say? They return go 5. That means from here. I get 120. So this is the backtracking. Recursive function is doing same work. Here you are doing same work. Number multiplied by next number. Same again. Instead of writing multiple loops, just say recursive. So this is the way a recursive function help us to solve the problem. So notice the same one problem we can solve the multiple way. So initially, whenever you are going to write the code, let's try to write the one program in the multiple way, right? Okay. So this is the kind of a factorial. So this factorial, what you get advantage simplified code. Recursion can simplify the code by breaking down the complex program into the smaller and more manageable piece. So here even up writing like factorial 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1. Okay. So complex this calculation, we simply say I am going to number multiply by number minus 1. Just I am simplify these questions in this, and in this way number we can pass. We can pass 5, 4, 3, 2, 1 and get the solution. So this is the solution. Recursive solution can lead the elegant to the intuitive solution. And this is the concept known as a divide and conquer problem. So this is your bigger problem. This is a bigger problem. So what you think, instead of I'm going to solve this whole number, I am going to divide the smallest number. Let's calculate only two part. First calculate one part, then two part, then three part, then four part, then five part, then six part. So in this way you can say I have just start 2 with a 1. I know factorial of 1, just multiply by the 2 and get the next factorial. Then multiply by 3, then get next factorial. Then multiply by 4, then gets the next factorial. Then multiply by 5, get the next factorial. So instead of going to the solve one shot, they are going to break down starting from 1. Then multiply by 2, get the number. So this is known as a divide and conquer, dividing a problem to the smallest part and again rebuilding the solution. Okay, so here there are some advantage and then is the disadvantage. Disadvantage what? The chaining. Let's this function, this invoke another function, invoke another stack call, another stack call, another stack call, another stack call. Now finally return. They go return back here, return back here, return back here, return back here, return back here. I finally get the output. So notice here what happened. This functions is still waiting for the result, 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 waiting for the result. So all required in memory, they are waiting. So if your chain is going to too much, high, you are getting out of memory exception. Why? Because each method requires some memory to hold to space. So this is the drawback. If you are going to calculate bigger number where your back track graph is so high, your program going to terminate. So this is the major drawback in the recur. They are writing very concise codes, very nice, but internally multiple methods are waiting to complete. So recursion is insufficient due to the repeated function call, which can lead the memory usage and the slower execution problem. Because the number of iteration your function invoke for the same time the method hours waiting to getting the output. But the simple while loop or imperative style code, we are just calculating, we are not waiting. So this is the one of the drawback in the recursive function. Okay, stack overflow. Deep recursion can cause stack overflow, which cause the recursive call or exceeded the maximum allowed depth. So this is the trick product, and this is also very hard to debug the code because they are doing the backtracking concept. Maybe you say invoke function this. So you are thinking, I am going to the here, 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 I am going to here, find the result. I mean this again very not think this is not the right solution to result. They are going to the back, they are going to the back, they are going to the back. So this is the kind of very hard to debug the code as well. So this is your kind of advantage and disadvantage of recursive functions. Okay, and some are use case very where recursive can help to solve problem very elegant, very simple, very concise way. If you are going to write manually using for loop, while loop, it will take a larger times. So tree reversal, maybe whenever we are going to learn tree is a kind of again data structures where say, hey, this is the one node, one value can have a multiple child, another value can have a multiple child, another value can have a multiple child, this have a multiple child. This is a kind of a tree and a graph kind of data structure. So where the recursive function is very helpful to traversing all the data. Maybe in future you learn like dynamic programming where the recursive is functions always help us to do the fast calculations of your dynamic programming. Sorting and searching, recursive function help us to use the sorting and searching algorithms. Graph algorithm like one node have a two child edges, these are connected here, these are connected here, these are connected here, these are connected here, these are connected here. So this kind of a problem also taken care by the recursive. So many places you can the recursive are used, but whenever you are going to use recursive, be carefully think how I am going to use the recursive function. Okay, and these are the some real world example as well as file system navigation. You can so within one folder going to the another two folder, again going to the another folder. These are the example. Recursive function can be used to navigate the your file system. Even you know XML and HTML parsing, they have a recursive function call to read all the node. Even the compiler interpreters are use the recursive function to implement the concept. Even the game developments, okay, where the recursive functions are very helpful. The recursive functions are many places you can say very help in the natures, and we understand. Okay, so this is all about recursive functions. Okay, and hope it will give a little bit idea and sense how we can complete our program not just as a one way, but think in the computer one program or one use case you can address the multiple way. So as initial programmer, we have to think each and everything very carefully. We have to learn right the different way. So almost this is the possible you feel comfortable when you are going to write some code, okay, to get the better understanding about the recursive functions. So that's for the day. Thank you.